All right, everybody, welcome to the video here for lesson number 11, the first video on solving system of equations with three variables. So for these questions where we have three variables to solve for, the biggest thing that you have to remember is you want to try and stay organized. So to stay organized here, I'm going to try and create like 6 areas that I can use. So now that we have our areas set up, let's set up what equations we want to add together. So just like we did with solving systems of equations way back when you were in Algebra 1, we want to try and eliminate a variable. So if I add the first and the second equations together, so if I add so if I add 4x plus 2y minus z equals 21 to negative x minus 2y plus 2z equals 13. The y's would cancel. That's going to give us the equation 3x plus z equals 34. All right, so now that I've used the first equation and the second equation, I now have to use the third equation. So in this other box over here, I'm going to put that third equation that we haven't used yet. And then I want to add that equation to one of the two that I already used. I'm going to choose to add it to the first one. Why? It's also going to cancel the y's. We want it so that the same variable cancels on both sides here. So now I have 7x plus 4z equals 91. And then I have to get it so that these two equations, when added together that I just created, would have a variable that also eliminates. So if I multiply this one by negative 4, I'm going to wind up getting negative 12x minus 4z, which we like, and 136, so negative 136. These cancel. So that leaves us with negative 5x is equal to whatever that adds up to. So 36 and so we get negative 45. Divide by negative 5, and I get x is equal to 9. Well, if x is 9, then I can find y, or z, whatever I have left, right? So if I use one of these two equations I just used, so instead of 3x, if I put 3 times 9 plus z equals 34, so we have 27 plus z equals 34, or z is equal to 7. And now that I know x and z, sorry, we can then find y. So if I do 4 times 9 plus 2y minus 7, because that's z, equals 21. So I have 36 minus 7, so I have 2y plus 29 equals 21, or 2y equals negative 8, or y equals negative 4. So now I know the system of equations has a solution of x equals 9, y equals negative 4, and z equals 7. For number 2, we're going to do the same thing. All right, so we're going to start here by making our workspaces. And unlike number 1, this one is not so easy. So there's no just straight up question that we can kind of just add up so that things cancel here. So what I'm looking for is two equations that have a positive and one equation with a negative for one of the variables. So if I look at the z's, if I add the first equation to the second or the third, the z's won't cancel. But if I take that second equation, so x minus 3y plus 4z equals 31, and add it to 4 times the first equation, so that's 8x plus 20y minus 4z equals negative 140. The z's cancel. We want the z's to cancel, or the x's to cancel, or the y's to cancel. The only reason why I chose z here is it has favorable signs, and I can easily multiply 4 times the first or 2 times, so we can get it so that they cancel. The other ones I'd have to do a little bit more multiplying. Less multiplying the better. That means we'll have smaller numbers to deal with. So if I add these two together, I have 8x plus 17y is equal to negative 109. So now I've used the second equation and the first equation. The only equation I've yet to use is the last one. Negative 3x plus 2y plus 2z equals negative 23. Well, if I want to get the z's to cancel, I again want to use that first equation, but this time I don't want to multiply it by 4, I want to multiply it by 2. So I'm going to make that 4x plus 10y minus 2z equals negative 70. The z's cancel, and I'm left with x plus 12y equals negative 93. Again, just like the first problem here, we were not able to just add these two together and have something cancel. So I'm going to multiply this equation by negative 9. That's going to give me negative 9x minus 108. Y is equal to whatever that is. Let me grab my calculator here. 93 times 9 is 837. Double negative, so that becomes a positive. So add them together. Negative 9x minus 108y equals 837. Big numbers, but everything will work out in the end here. So if we do the negative 108 and positive 17, I get a negative 91. And if I do my 837 and negative 109, I get 728. Divide that by 91. And we get y equals negative 8. So although we had to deal with some big numbers there, nothing we can't do. We have a calculator, right? So now that I know y, I have to plug in y to find x. So instead of x plus 12y, I'm going to do x plus 12 times negative 8 equals negative 93. So then if we go through and do our multiplication there, move some terms around, right? I have x minus 96 equals negative 93, or x equals just plain old 3. Now that I know x and y, I now have to try and find z. So I could say 2 times 3 plus 5 times negative 8 minus z equals negative 35. So I have 6 and negative 40, so negative 34 minus z equals negative 35. Or negative z is equal to negative 1, or z is equal to positive 1. Not too bad. Let's keep going. 2 more. So the next one, we have to think a little bit more here about what to multiply. Or really, essentially, you're trying to figure out what variable do I want to try and eliminate. All right, there's always an easy one and challenging ones. So if I look at the z's, I have 2, 3, and 8. Nothing really that I like there. right? I'd have to make the 2's and the 3's both 6's. I'd have to make the 8 and the 3 both 24's. So we really don't have anything there that's favorable. Same thing happens with the 3, the 5, and the 2. I do like the x's, so let's get rid of the x's. So let's start with the last one, negative 6x, only because it's the one with a different sign, minus 2y minus 8z equals negative 50. If I multiply the first equation by 3, I would get 6x plus 9y minus 6z equals 99. X's cancel, and I have 7y minus 14z is equal to 49. And if you're real smart, you see that all of those have a common value of 7, so that equation can be simplified to y minus 2z equals 7, making the number smaller. Do you have to do that step? No, but it might help, so I'm going to do it. All right, so now I've used the last equation and the first equation. The only one I have not yet used is 4x plus 5y plus 3z equals 54. And again, I want to try and multiply something by one of the two equations I just used to make it so that x cancels. So if I was to try negative 6 here, I'd have to multiply something by both equations. I don't want to do that unless I absolutely have to. So I'm going to go back to the first equation again, but this time I'm not going to multiply it by 2 or by 3. I'm going to multiply it by negative 2. So that's going to become negative 4x minus 6y plus 4z equals negative 66. So again, I'm taking this first one and multiplying it by negative 2 here. Here, I'm multiplying it just by positive 3, just so that they wind up having x's that cancel, leaving us with negative y plus 7z is equal to negative 12. Look how nice that is. Because we divided that by 7, I get a y and a negative y. They already cancel. So I get 5z is equal to negative 5, or z is equal to negative 1. So by noticing some structure and essentially factoring, right, we're able to see that we can make it easier, right? So always look for those kind of patterns and things that show up. So now I know z is negative 1. So if I plug that in, I can say y minus 2 times negative 1 equals 7, or y equals 9 if you solve that. So I know y and I know z, so if I do 4x plus 5 times 9 plus 3 times negative 1 equals 54. So that's 4x. So we got 45 minus 3, so 42 equals 54, or 4x equals 12, or x equals 3. Look at that. Now, nice thing about questions 1, 2, and 3 is if you followed what we did in class, you were able to also check these in the calculator by setting up a matrix, plugging in the coefficients, and doing reduced row echelon form. I'm going to post a separate video explaining that process. It's not me talking, it's somebody else I found on YouTube talking, so just kind of bear with it, and it's the same steps we did in class. Number 4, also similar to one that we did in class. So although this looks way challenging, it's not actually that bad. So looking at the first and third equation, if I do 1 over x plus 1 over y plus 1 over z equals 5, that's a z, not an x, and 1 over x, I don't have a y, minus 1 over z is equal to negative 2, the 1 over z's cancel. So that's going to leave me with 2 over x plus 1 over y is equal to 3. Now, if you notice, this equation does not have a z. So if I was to multiply this by negative 1, the y's cancel. So I've eliminated z's, and now I've eliminated y's. So I'm left with the equation 1 over x is equal to 1, telling me x must be 1. Notice I did that without ever having to use this box. The reason why? The missing variable, right? We actually could have done this one with the challenge question that was in class that we did, but I didn't want to. I wanted to see if anybody saw that and was able to see it on their own, right? If you didn't and you started just adding y's together and x's together, totally fine. You're going to get the same answer. So now that I know that x is 1, I could say 1 over 1 plus 1 over y equals 2. So I have 1 plus 1 over y equals 2, or 1 over y equals 1, so y equals 1. And since I know x and I know y, I now can find z. I don't even have to plug back into the first equation. I could use that third one, right? I could say 1 over 1 minus 1 over z equals negative 2. What's that going to be? So it's going to be negative 1 over z equals negative 3. Well, the only way to make that work is to make z positive 1/3. Cross multiply, divide by negative 3, and you wind up getting positive 1/3 for your final answer there. Hopefully this video helped. Again, watch out for that second post of the random guy I found on YouTube showing you how to do it on the calculator. Again, like we said in class, though, the algebra is important because I'm never going to ask you just to do it in the calculator. But the calculator is a quick and easy way of just checking that you got the right answers. All right. So hopefully you're enjoying your weekend. I'll see you all on Monday.